that feeling when you're riding in the woods at high velocity, downhill, and you really want to do a drone shot with the drone shooting between the trees? Nope, me neither. But apparently for Mick next door, that's a recurring problem to him. So he came in here and asked me if we could do something called a cable cam. He'd been looking online and he found that viral cable cam and he showed it to me. And that looks basically just like some kind of device running up and down a cable with a camera strapped to it. That's all it is. Now, what else do we know that is a remote controlled motor that can go in either one direction or a different direction? An RC car. So that's the idea. That's our plan at least. So, well, Mick went in, he bought an RC car, we had it delivered, and take the parts from the RC car, strap it down, put it onto the 3D printed parts, and then bada bing, we should have a cable cam. Yeah, hopefully it's that easy. So this is the RC car, and it seems to be some kind of standard RC car since we've seen a couple of brands have the same frame underneath the cover. The RC car here we got actually consists of a motor with a reduction gearbox up here. There is another motor here that controls the steering through a bevel gear. There's some shock absorbers, battery box here. The electronics is under here and it's connected to this very cute little antenna. Can you see it? Here. And the controller is here and it has on off, on off, on off, on off. That's it. There's no speed control in this car. That's what we have to deal with. Anyway, let's strip this RC car down, turn it into a cable cam. So this is basically the design I came up with. In the end, I ended up using the battery pack, the drive motor, the electronics, and one front wheel for this attempt at a cable cam. I'm heavily inspired in the design by the viral cam, obviously. It has two arms that flips up against the hard stop. At the end of the arms there are two rollers, and these rollers will ride the wire itself, and then in the middle is a drive wheel. That's actually the front wheel of the RC car. This drive wheel will then propel the robot in either one direction or the other direction based on the inputs from this. And that's all there is to it. So let's just start printing all these plastic parts, put it together and see if this actually works or if it's just a heavy waste of time and we need to design something completely new. Guess we'll see. Let's make this cable cam. Okay, we're testing the gears and to see if when we turn this gear, this pinion will also go. And it does.
Oh, that's so satisfying. So it's going to hook up with AA batteries. I got the controller right here.
Okay.
You tell me when you're ready.
I don't know if I'm ready. Just press it. Do something. Okay.
Nothing happens. Anticlimax.
It's totally anticlimactic. So yeah, we made it. Well, the motor's strong enough to run the RC car because there was a gearing that in my infinite wisdom I decided to just not use here. And lo and behold, it doesn't work. I also want to slim down this body because that's way too big and there's too much wiggle room in the arms here, so we need to tighten up the tolerances. The wheel actually grinds up against the sides when it's attached up here because I didn't take into account that a little bit of the hub is sticking out. Let's fix all those issues, reassemble it and see if we can get it to work that way. And if not, we might have to just ditch the whole idea of using this little tiny RC car. Let's cross that bridge when we get to it. Yeah, so we got to that bridge, we crossed it.
Alright, so I know that Casper had been working on the new design for the version 2 all night long. Hey Casper.
I mean, this is hopefully the new design.
Wow, this looks good.
The idea is we changed a lot.
Yeah, I see.
So basically, this is everything I'm gonna use from the RC car now, because everything else is not big enough.
Okay, so what, we're still using the wheel?
We're still using the wheel, we're still using
the communication, right?
We're gonna use this, that's the only thing. And that reminds me, I've forgotten about the switch. So we need to put in a switch somewhere in here.
Okay, can you show me around this one?
We have a little 9-volt battery here, so we can power the whole thing. The mounting of the wheel is different now, it's more like it is on an RC car. Because I realized that we could do that.
Where does all the electronics go?
Oh yes, the electronics is in here.
Oh nice.
So down here is the Arduino Nano and our motor driver. So that's basically where we are. I need to draw all this and finish it off, and then we start printing at some point.
Perfect.
Soon. I just finished now designing the second version of the cablecam based on an RC car, and at this point it's a bit of a stretch to say that, since I only have 2 components left. I still have one of the front wheels to use as my drive wheel, and I still use the electronics for communication, and communication only, because I couldn't be asked to do my own Arduino controller and blah 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 blah. I decide to say that this is okay. I'm still turning one thing into the other. I'm just applying things like a 3D printer, an Arduino Nano, a motor, an H-bridge, a 9-volt battery, and I have a battery holder. I never really felt the motor in the original was strong enough, especially after we saw the first prototype. It just felt flimsy, you know, it just wasn't skookum enough. So I went through my cupboards and I found an old motor I stripped out of an HP printer at one time some years ago. I have no data on it, I have no measurements on it, nothing. It just feels stronger, I guess. Yeah, what we need to do now is just again print all the plastic parts. Then I have to get all the electronics together, write a program for the Arduinos. So I've managed to assemble all the electronics. I've hooked up a power supply to act as a 9-volt battery, and I'm ready to just basically start programming it. When we have a look at this, there's basically 2 inputs, and one of the main things we would like to do now that we actually have a double H-bridge in here and an Arduino is we want to be able to control the speed. And we can do that with this. So I want to make kind of like a table of speed levels that I can switch between by using this thing. But that means I also need to program up a transition between these speeds, i.e. I need to program an acceleration control. So that's a little bit more fun to get working on this project that was supposed to be not that big. Let's get to it. Here I am only like, what, 12 hours later. I actually thought I had it a long time ago, and then everything was working just the way I wanted it to work, and then I gave the whole thing to Mick and say, hey, look Mick, look, I made it, and he immediately made it not work. It wasn't working the way he was expecting the whole thing to work. So back to the keyboard and reprogramming the whole thing, but now it's working. Let's go 2 speed levels up and go forward. 1 more speed level up, yes, 1 more. This is the fastest. And then slow down. Now just what we need to do is build, and hopefully everything will work when we put it together.
So it's the breakout board?
It's not, it's more like a mounting board, so I have screw terminals instead of just pins. Yeah, it also makes the whole thing higher, but it makes it easier for me to mount.
Yeah.
So that's why we decided to use it. I decided to use it. And then, of course, if we want to slim this down, it's one of the things that will be pulled out. No! But it's moving. But it's kind of stuck.
It's trying.
But it's stuck. So it turns out you can't just wing it when it comes to gears, and especially when you design and 3D print them yourself. So I had to do the actual calculations to figure out the proper center distances, and after that a lot of experimentation to also figure out the proper tolerances for these gears so they don't just lock up when they're turning around. Now I had to reduce the friction of the gears, so I borrowed some grease from Mick and ended up greasing the whole thing up. Then came the issue of also keeping the gears locked to the shaft, and I had to figure out a way to do that, and I ended up finding a little 3mm aluminium wheel hub with a set screw so I could attach the gear properly to the drive shaft. And last but not least, the gear ratio. I originally designed it to have a gear ratio of 8.17 to 1.
Okay, ready?
Yes.
And we tested it out and it worked beautifully, but it was just not fast enough. So I designed a new gear with a gear ratio of 3.5 to 1.
3.5 gearing.
And it made absolutely no difference because now I didn't have the torque to move it. It turns out my sweet spot gear ratio was 5.25 to 1. When the gears were in place, then came the next issue, because the 9-volt battery I was using was just not able to deliver what I needed.
Okay, but we definitely...
But this is the slowest cable cam ever.
Yeah, but it's definitely under power.
So I hooked up my lap power supply to this thing and was running around with it up and down the string, and well, turns out I need 12 volt, which I kind of suspected but really hoped I didn't have to deal with. But I do. It's a 12 volt motor. So I don't know of any 12 volt batteries that fits within the same build size as a 9 volt battery, so I bought a 3-cell LiPo battery of 650 milliampere hours. However, when you decide to utilize a LiPo battery, you also need to consider the protection of the LiPo batteries. So I need to implement a BMS, or battery management system, that will protect the battery from discharging too much, because that will actually break the battery. Also, I need to figure out a way to connect this LiPo battery to the rest of this thing, so I have to design a connector board. And with a LiPo battery, a BMS, and a connector board, that means I have to redesign this part so it all fits within this frame. And that's pretty much where we are right now. The big test.
Finally the big test.
Finally the big test. So we put a line up here, and Mick has a plan of going under a couple of times on a mountain bike, and then we'll shoot the camera down through that line, and it's about 30 meters, so we have no idea if this is gonna work, so let's go test it.
Of course it's gonna work. Come on, Tarzan, let's go test it. Yeah!
Okay, we're gonna check out the actual footage now, and hopefully everything is gonna be perfect.
Fuck the fit.
This time we're gonna try and see if we can get the camera a bit ahead of Mick. The initial shots on the phone looks really cool. So far it's a decent success.
Hvordan sker det der?
Like there. here, here. So, no more today.
That was it for today.
That was it for today. Watching the end result of all of this work is just so satisfying, and the fact that you can't get this kind of footage with a drone just makes it even better. Well, Mick is also gonna make a video where he explored the cablecam and its capabilities a lot more in his video, and I'll link it in the description when it comes out. To finish the video off, I thought I'll show you all of my failed components and all of my failed prints, because developing a project like this really requires a lot of prototyping. So F in the chat for all of my casualties during this development.